actually gave you the equation though, so let's go ahead and write that out. We've got KCl reacting with O2 to make KClO3. We need to balance this. I see there's 2 oxygens here on the left, so I'm going to need 3 and 3 on the right, so I'm going to need to take those both to 6. So I'll put a 3 here, put a 2 on the other side. That gives me 2 potassiums and 2 chlorines, so I'll have to put a 2 here to balance it. Now when we read this, let's make some notes. If 50 grams of KCl, so I have 50.0 grams of KCl reacting with 50.0 grams of oxygen, how many grams of KClO3 will be formed? So I'm looking for grams of this guy. Now, since I was provided the mass of both reactants here, I'm going to have to determine the limiting reactant. The easiest way to do that is just to convert this 50 grams of KCl to grams of KClO3, and then convert this 50 grams of O2 to grams of KClO3, and then whichever answer is smaller will have to be my actual answer because that will have come from the limiting reactant. So we'll just start with the 50 grams of KCl, 50.0 grams of KCl, converting that, 74.55 grams of KCl is 1 mole of KCl. We don't want mole of KCl, so it's going to go to the bottom. We want mole of KClO3. I see a 2 and a 2, so it's a 2 to 2 or a 1 to 1 ratio, 1 to 1. And last, 1 mole of KClO3 has a molar mass of 122.55 grams KClO3. When you plug this in your calculator, top times top, 50 times 122.55 divided by 74.55 equals to 3 sig figs, 82.2 grams of KClO3. So understand what this means. This means if I'm going to react all 50 grams of this KCl, I'm going to make 82.2 grams of KClO3. Well, now I need to do the same thing with the oxygen. I have, let's change colors, we'll go blue, 50.0 grams of O2. Getting rid of the grams of O2, going to moles of O2. 1 mole of O2 is, whoops, let's try that again, 32 grams of O2 because it's diatomic. Putting mole of O2 on the bottom to cancel, I'm going to moles of KClO3 again. This time it's a 2 to 3 ratio. And I get to just reuse this exact same molar mass from right here, 122.55 grams of KClO3 is 1 mole of KClO3. Again, the calculator, multiply across the top, 50 times 2 times 122.55 divided by 32 divided by 3 is to 3 sig figs 128 grams of KClO3. Now interpret what that answer means. If you wanted to use up all 50 grams of O2, you would make 128 grams of KClO3. Now, we know that's not possible because, according to this one right here, you can only make 82.2 grams of KClO3. So this means this is our final answer. The smaller value is the answer. This is the amount of grams of KClO3 you can make. This question didn't ask, but the limiting reactant then is right here, this KCl. Since it's the reactant that produced that amount of KClO3, the KCl must be the limiting reactant. For question 2, we've got an equation that's not balanced, so let's go ahead and balance that. I see there's 2 nitrates here. Let me switch to a different color. 2 nitrates here, so I'll need a 2 here. And that looks like it actually balanced everything. So let's read it. If 34.5 grams of copper, 34.5 grams of copper react with 70.2 grams of silver nitrate, what's the maximum number of grams of silver that can be produced? I'm looking for grams of silver. Again, I was given both reactant, so I'm going to have to do this twice and pick the smaller answer, starting with the copper. 34.5 grams of copper. I don't want grams of copper. I'm going to moles of copper. 1 mole of copper is 63.55 grams. Canceling out moles of copper to the bottom, I'm going to moles of silver. According to this reaction, it's a 1-to-1 ratio. And 1 mole of silver has a molar mass of 107.87 grams. Plugging this in, 34.5 times 107.87 divided by 63.55 is 58.6 grams of silver. If I were going to use all this copper, I would expect to get 58.6 grams of silver. And let's do the same with the silver nitrate here. I have 70.2 grams of AgNO3. Don't want grams of AgNO3. I need moles of it. Obviously should have made that parenthesis a little bigger, huh? 1 mole of this, adding together the molar mass, 107.87 plus nitrogen's 14.01, plus 16 times 3 for the oxygen, is 169.88 grams per mole. Mole AgNO3 to the bottom. Mole of silver to the top. 1 mole of silver is ratioed to 2 moles of silver nitrate. No, I'm sorry, I didn't balance this correctly. That should be a 2 right there. Sorry about that. So that's going to be a 2 right there. And now 1 mole of silver still has a mass of 107.87 grams. 70.2 times, that's a 2, not a great one, but that's a 2, times 107.87 divided by 169.88 divided by 2. And I get 44.58 grams of silver. Again, the smaller answer is the real answer, so this is the maximum amount of silver I can make. And if the question were to have asked, that's because AgNO3 is the limiting reactant. Question 3. Question 3's got a balanced one, so let's just go ahead and read it. 85 grams of ammonium chloride, only 2 sig figs, 85 grams, reacts with 130 grams of calcium hydroxide, 130 grams. What's the maximum mass of ammonia, which is this guy right here, that can be made? So I'm looking for the grams of this guy. Again, we'll take them both to that. Smaller answer is the real answer. 85 grams of NH4Cl. I don't want grams of NH4Cl. I want moles of it. 1 mole, we'll add this up, 14.01 plus 1.008 times 4 plus 35.45 is 53.492 grams. Mole of NH4Cl to the bottom. Moles of what I'm going towards, which is the NH3 on top. And the coefficients show me it's a 2-to-2 ratio, so that's a 1-to-1 ratio. And now 1 mole of NH3 to grams of NH3. 14.01 plus 1.008 times 3 is 17.034. Multiply across the top, divide across the bottom. And it looks like 27.1 grams of NH3. Doing the same thing for the calcium hydroxide. 130 grams of CaOH2. grams of CaOH2 to the bottom, mole of it to the top. Adding that molar mass, 40.08 plus 16 times 2 plus 1.008 for hydrogen times 2. 1 mole is 74 point, let's call it 10. Mole of CaOH2 on the bottom. Go into moles of NH3. Coefficients tell me it's a 2-to-1 ratio. And again, this guy's going to match the one right above it. So 1 mole of NH3 is 17.034 grams NH3. Plugging this one in. Looks like I'm going to get 59.8 grams of NH3. So again, I have to go with the smaller answer. 27.1 is going to be my answer. And the limiting reactant was NH4Cl because that's the one that produced the smaller answer. Number 4, you got 25 grams of NH3. 96 grams of H2S. What's the maximum amount of ammonium sulfide that can be formed? So I'm looking for grams of this guy. Doing exactly the same thing again. 25.0 grams of NH3. We actually just had his molar mass from the previous problem. 1 mole of NH3 is 17.034 grams. Mole of NH3 to moles of what I'm looking for, which is the NH42S. And that equation was balanced for us. So it looks like it's a 1-to-2 ratio. 1 mole of NH42S. We'll need its molar mass. We got 14.01 times 2 plus 1.008 times 8 plus 32.07 for the sulfur. Gets a 68 point, we'll call it 15 grams of NH42S. Multiplying those, dividing across the bottom, and to 3 sig figs, it gives me 50.0 grams.